Science Academy, the science provider of the nation.
So Assalamu alaikum everyone. So I plan to do numbers for you guys today. So how the flow chart of numbers works, right? So initially we will get on to that, and then we will try and go to the number lines and directed numbers and all these kinds of things later on, right? So initially, if I put a topic as numbers, numbers can be divided into two as real numbers and complex numbers. As far as for the O-level students, as far as you are concerned, right, we don't learn about complex numbers, right? We are not going to study about complex numbers. So we are going to go towards the real numbers, and from real numbers we are going to go towards rational numbers and irrational numbers. Now you might wonder what this R is, right? So this R is the symbol for real numbers, and it is called as the curl R. You call it as the curl R, C-U-R-L R, right? And this is called the rational number, and the rational number has the symbol of curl Q, and the irrational number has a symbol of curl Q complement. So my question to you guys is, what is this real numbers, what is this rational numbers, and what are these irrational numbers actually means, right? Now whatever the number that you know, right, whatever the number you know, it may be 2.1, 2.5, 7.3, 8.9, 3.333, 3.45, 3.45, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So likewise if you have something like that, or trillion, thousand, 122, whatever the number you know in this world, whatever the number you can write, it is called a real number. Now what are complex numbers? Complex numbers, of course, something that is very they are imaginary numbers. For example, if you take root of -1, you don't have the square root of -1. So if you take square root of -4, you don't have the square root of -4. So these kinds of numbers are called as the complex numbers. So these two are the numbers that you are supposed to learn, but for your level, for the ordinary level, you don't have complex numbers. So we are going to learn only about the real numbers. So when you consider real numbers, you have the separation of rational numbers and irrational numbers. So under real numbers, all the numbers are going to come, all the numbers that you know, right? So if I want to say about irrational numbers, right, we will talk about irrational numbers lately in a wide range of we will study it extensively. But if you consider rational number, if you can write any number as a fraction, for example, if you take 3, this 3 can be written as a fraction, 3 over 1, right? If you take 3.3333, like that, this can be written as 10 divided by 3, right? If you can write a certain number in the form of fraction, then it is called a rational number, right? So for example, if you take square root of 2, this is going to be 1.41 something else, it's going to go up until the end without having a pattern here, right? If you have a pattern like this, 3.333, or suppose if you have 2.414, again you have 414, again you have 414. So if you have a kind of a pattern like that, 414, 414, 414, if you have a pattern like that, you can obviously, you can write it as a fraction. You can write it as a fraction. If that was the case, if you have a certain pattern, this is going to fall under rational numbers. But in this case, root 2 doesn't have a pattern continuing, 1.41, you can't predict what number is coming next. You cannot predict it, but you have to find it, right? For example, if you consider pi, it is 3.14 something else, it's going to go like that, right? People say it is 22 over 7, but 22 over 7 is just an approximation. It's not the real number, right? It's not the exact number of pi, right? So the exact number of pi is 3.14 something else like that, right? So if you say 22 over 7, up until the second decimal place it works, but after the second decimal place, 3.14, that is okay. But after that, the contradiction and the problems are going to arise. So pi is an irrational number. So root 2 is an irrational number. Root 3 is also an irrational number. So because 1.71 and it is going up to infinity without a pattern, right? If you have a pattern, right, you call it as a recurring decimal. If you have a pattern to the decimal place, it is called a recurring decimal. So if you have a finite decimal or a recurring decimal, it's always a rational number. And if you have a decimal which is going up until infinity without a pattern, then it is called an irrational numbers. So these kinds of idea is very important when you learn real numbers. I know that these kinds of things are very boring to people. They don't study at all. But these are the very basic building blocks of the numbers.